So I just explained why high definition tDCS as opposed to regular tDCS may provide increased capability to conduct hypothesis-driven clinical trials that deliver current to specific brain regions, um, and maybe we'll be able to produce more targeted outcomes because other brain regions are not stimulated. I should also say that high definition tDCS has a lot of advantages when you're looking at the damaged brain. So this is an example of a brain where there's been a stroke and a part of that brain has been destroyed. And in this case, the target is right around that lesion. Using high definition tDCS, it's possible to optimize current flow so that it's delivered to just the region of interest where you want to enhance neuroplasticity as part of a rehabilitation regime while sparing much of the head. A majority of clinical trials with tDCS right now don't use high definition tDCS, including those that are looking at stroke, and they have shown positive results. So it's not to say that using conventional tDCS and not being focal um, um, is not going to be clinically effective. But from a design perspective, it's unequivocal that using high definition tDCS will allow you in a much more targeted and specific way to get to your target. And again, this may support both hypothesis-driven research, but also specificity. Here's a very illustrative example of two approaches that are currently being used to treat depression. One is a large trial being run in Brazil, led by Andre Benoni, the SELECT and also ELECT trials, where the target is the DLPFC. Another one is a large multi-center trial being led by Conling Liu. She's in Australia, but the centers are actually in the United States. And they use slightly different electrode shapes, 5x5 and 5x7 in positions, and slightly different current. But in both cases, the target of the intervention is the dorsolateral prefrontal cortex, which is the target I discussed before. Now, this is the dorsolateral prefrontal cortex right here. It's a rather small region. Now, by using conventional tDCS, which is used in both these approaches, and placing large electrodes across the front of the head, current is predicted to get to the DLPFC in both cases. But of course, it's going to stimulate much of the rest of the brain as well. So while both these montages do get current to the DLPFC, you couldn't say that they are targeted to the DLPFC. They stimulate much more of the brain. So they're targeted in that sense, but they're certainly not specific. And if you look at tDCS in its totality, so tinnitus and migraines and pain and all these other indications as well, again, a majority of trials were conducted with conventional tDCS, and conventional tDCS will usually stimulate between a third to 75% of the brain. And so it is hard to say, because a majority of trials use diffuse tDCS, that tDCS is specific because we guide current to specific parts of the brain. That's obviously what I suggested to you earlier, that the specificity of tDCS derives from the ability to deliver current to specific parts of the brain and not others. But with conventional tDCS, which is being used in most cases, it's not focal. So therefore, there must be some other reason why tDCS is being made specific other than just anatomical targeting. And so I want you to go through another thought exercise, and I want you to think about weights. And weights could even be a brick sitting in a gym. Now, if I told you that that brick can help you train for golf and it can help you train for skiing, that brick can help you be a faster runner and a better ping pong player, you would believe me, because in all these areas, people use weights to improve their performance. And the reason you believe me is because these weights are not being used on their own, but they're being used in conjunction with a specific kind of training. So if you wanted to run faster, you would use weights in conjunction with some sort of leg exercise. And depending on what you wanted to get better at, you would use weights in a very specific way in combination with a training regime. And that training regime is actually what provides specificity. And it even goes deeper than that. If you look at a brick doesn't make you grow muscles. Just staring at a brick doesn't make you stronger. It's using that brick or that weight in conjunction with a training and an exercise. A brick can't make you grow more muscle. Muscles are extremely complicated. But your body has an innate ability to generate more muscle when it's challenged in a specific way. And the weights help you produce that challenge. Now, if you train your right arm with a weight, then your right arm will get stronger, but not the left. So part of this also has an inherent specificity to it. So we're comfortable thinking about that in terms of sports. We can also think of that in terms of electroceuticals and specifically tDCS. We should think of tDCS as a tool to enhance ongoing training or ongoing therapy. So the 9-volt battery of tDCS, it can't make your brain better on its own, but maybe you can make your brain better through training. And what we're using tDCS is to make that training more effective. And what you train on, let's say you're training on mathematical skills or you're training to feel better, what you're training on is what the tDCS will help you get better at. So this notion of using tDCS not on its own, but as an adjunct to some other therapy, really helps us address the two questions I mentioned earlier, which is, how could tDCS, such a simple technique, work for anything? Well, just like a brick, it doesn't produce the effect, it simply enhances something that's already going in the body. And the second question was, how could it be so specific? Again, it becomes specific by being matched with some specific type of learning. So we can think of tDCS as a tool for the mind, a brick for the brain, that enhances ongoing brain processes, enhances plasticity, enhances cognitive training, and so on. And in fact, if you look at the majority of tDCS human trials, they're often combined with some sort of brain training. So if you want people to get better at math, you don't just apply tDCS while they sit there. You train them intensely at math while you apply tDCS. If you're using tDCS as a tool in neurorehabilitation, let's say to enhance motor loss after stroke, you don't just give people who've had strokes tDCS. What you do is you give them intense physical therapy, maybe using robots, and then you use tDCS at the same time to make the training provided by the physical therapist or the robots more effective. Now, tDCS can also have another effect, which is a potentially deep effect on mood, on sort of deeper brain functions that relate to vigilance and relaxation. And it turns out that this also is a basis for specificity. So if I have an intervention that makes you more alert, and I then give you some sort of cognitive training, that cognitive training will now be more effective. If I give you an intervention that makes you more vigilant, and so on. And so when we talk about effects of tDCS that affect brain functions related to attention or general mood, and again, we combine now tDCS with some other form of training, that training can now be made more effective. And there's even an idea that tDCS can boost the placebo response. So the placebo response is a well-known effect that occurs in many therapeutic conditions. Just thinking that you're going to get better can make you better. And placebo is not simply a psychosomatic phenomenon. There's actually a physical change that occurs in the brain as a result of the placebo effect that often mimics the effects of the medication themselves. So, for example, a placebo effect in pain control can activate many of the same parts of the brain as an opioid. And so placebo is a real effect that anybody who's enrolled in a trial will experience, and tDCS may be a way to actually boost the placebo effect. And if you're having a placebo effect in regards to pain control, tDCS will specifically boost that placebo effect. And so we can think of tDCS not as a technique that's being applied on its own, but as a technique that's being applied as adjunct to cognitive training. In this case, you can see an individual who's getting a 4x1 HD tDCS, but they're also getting cognitive training at the same time. And the hypothesis is that the specificity of the technique doesn't simply come from delivering current to just one part of the brain, but also the fact that the individual is undergoing a specific training task, and the fact that they're training on something in particular means that the tDCS will have a very particular effect as well. And so tDCS enhances just trained tasks by being combined with the tasks. Now, up to now, this has been a very sort of hand-wavy idea, but there's actually a foundation for this in neurophysiology, and this is something that we call functional targeting. So functional targeting is the cellular mechanism by which tDCS enhances just a task that it is being combined with. And there is quite a bit of evidence to show that functional targeting is a plausible mechanism for how tDCS is specific. So we need to go from anatomical targeting to functional targeting. With anatomical targeting, I want you now to think about a part of the brain with cells that you want to stimulate, let's say the green cells, and cells that you don't want to stimulate, let's say the gray cells. So with anatomical targeting, when we put an electrode over part of the brain, we're going to produce current that flows over some part of that brain. And no matter how good we are with anatomical targeting, even if we use high definition tDCS, even if we send the current to only one particular gyri in the brain, we're going to be stimulating different cell types. And these cell types, the way I've illustrated them here and the way they actually exist in the real brain, they don't exist separately, they overlap. And so with anatomical targeting, even with using high definition tDCS, it's not possible to stimulate cells involved in just one task. Let's say that task is depression, while avoiding cells involved in some other task, like remembering where you left the keys. Anatomical targeting has an inherent limitation. Functional targeting takes it a step further. Functional targeting presumes that for some reason, the green cells, the ones we want to activate, are behaving differently than the gray cells, the one that we don't want to activate. Now, why would this be? Well, maybe we're making the person think about something. Maybe the person is having a placebo effect. Maybe the person is receiving some sort of training that's specifically activating those green cells. And the theory of functional targeting says that because the green cells are active in a different way than the gray cells, only the green cells receive the benefit of tDCS. So even though current is flowing everywhere, even current could be flowing across the entire brain, because there's a specific group of cells, a particular network in the brain that is active during the application of the tDCS, tDCS will just affect those cells and not others. And so that is the basic theory of functional targeting, which is not to replace anatomical targeting. It's still rational to deliver current to specific brain regions, but it is something that can act on top of it and with it.